So good afternoon, everybody. Welcome to Tox Talk. My name is Joseph Jones, Chief Operating Officer here at United States Drug Testing Laboratory. Today, we're going to talk about phosphatidylethanol. Phosphatidylethanol is a direct long-term alcohol biomarker that is formed only in the presence of ethanol. And once formed, it's incorporated into your phospholipid membranes of your red blood cells, and there it remains for days to weeks. And so this has become an important tool in our business of monitoring for abstinence. And so there's a couple of things that it would be a good idea for us to cover today. And first, you know, this COVID thing that we've been living through, oh my gosh, won't we all be so happy when this thing goes through, sails out to sea, and it is over. And so, you know, for us, it's just an inconvenience. But for our clients, this is like a real problem. The COVID environment is not a good environment if you're in recovery. It poses lots of issues because of the fear, uncertainty, and doubt that we are living under with this COVID over our head. During this period of time, we've also had a lot of discussion back and forth, and even it's come up in litigation about the effects of hematocrit on PETH. So there's a paper we'll review on that was published a couple of years ago. And I had overlooked it, but in preparation for a case recently, I had a chance to kind of really dig down into it, and I will share that with you today. We're also hearing a lot more questions about do ethanol-containing mouthwashes affect our PETH levels. There's a recently published paper on this, and we'll go over that as well. Last but not least is the effect of ethanol-based waterless hand sanitizers. And we are participating in a study. It's unpublished as of yet, but we got permission to share this data with you today. And the study is not complete, but we have some really good information that we can glean from what we have so far. So this past summer, there was a webinar hosted by the Research Society on Alcoholism on behalf of the National Institute of Alcoholism and Alcohol Abuse. And Dr. George Koob was the featured speaker, and it's important to note he is the director of the National Institute of Alcoholism and Alcohol Abuse. And he had three distinguished guests that talked about the effects of COVID and alcohol use with regard to just the overall atmosphere that we were just mentioning a second ago, with respect to people getting access to treatment because of quarantine and limited access and social distancing. And Dr. Thomas talked about the implications of research that's going on. And so a lot of the research was halted for many months this spring and summer. One of the papers that Dr. Koob recognized in his portion of the speech dealt with COVID-related distress and how that affected alcohol use. And this was like a large survey of general population. And they have this measure that they've devised that measures the COVID-related distress. How distressed are you about COVID with your family, with your community, with your job, etc. And the findings of this general population I thought was interesting, and I share that with you here. The outcome variable of maximum number of drinks on one occasion, that rate is up, and it is associated with the COVID-related distress, 7%. And this is a general population. And that 7% was a statistically significant increase. The number of drinks on a typical occasion is up 8%. The number of drinking days was up 8%. And the number of heavy drinking days was up 8%. So all three of these measures are up 8%, and these measures are statistically significant, as you can see with the 95% confidence interval. So with keeping this in mind, that this is a general population, how does this affect our population, which is a high-risk population? So it would be my guess it would be a little more. The next paper was presented by Dr. Barbosa down at RTI. They did a large survey nationwide looking at alcohol consumption at two different time frames, right before COVID-19 and then after COVID-19. And what they published was that the average drinks per day is up 27% in a general population, up from 0.74 per day to 0.94 per day. 27% increase, and that increase was statistically significant. A second measure that they reported was that of those that reported drinking, binge drinking was up. 22% in February, 27% in April. That's a 26% increase, and that increase is a statistically significant increase. So with these two studies, and of course listening to the remainder of that webinar this summer, started to think, what are we seeing at USDTL? Are we seeing similar trends with our high-risk population? So we pulled a query of our database going back to the beginning of 2019 up through the end of the third quarter of 2020. And this is what we found. We found a very significant looking trend here from 2019 to 2020. And on further review, it looks like that the 2019, we're sort of hovering around the 29.6, bouncing back and forth around that. And then in 2020, it jumps up to 33.3%. I analyzed that by chi-squared, and that is a significant increase statistically, going from 29.6% to 33.3%. So considering the demographic that we're testing, a high-risk population, it seems that these increases are mirroring the observations that these other two researchers had reported. So with this in mind, we can look at some literature. But before we move on, again, phosphatidylcholine is catalyzed by phospholipase D in the presence of ethanol to form phosphatidylethanol, and that's embedded in the phospholipid membrane of the red blood cells. If ethanol is not present, it uses water, it makes phosphatidic acid, and then it goes off and does some other reactions in the process of life. So the question we have is hematocrit. This is the first question. So there's a paper by Coomer that was published back in et al. Back in 2016. And so as a review, hematocrit is basically a ratio of the solids and liquids in a blood sample. And there's some rather narrow ranges that they exist in, and they are gender specific. So for men, the normal range of hematocrit goes from 0.41 to 0.50. And for women, it goes from 0.36 to 0.48. These are the normal ranges. So in this study, they had two volunteers who were inpatients in a withdrawal situation. They were being monitored in an addiction setting. And they took these specimens and they analyzed them. And then they took the specimens and adjusted different aliquots, hematocrits. And they adjusted the hematocrit of these different samples from 0.2 to 0.6, and they made a replicate of these samples. And here were their findings. Now, they were looking at 3 different PETHs. And so for the bottom 4 charts, we can dismiss those for the purpose of this discussion. But the top 2 charts are for the PETH 16-0-18-1, which is the most predominant of the PETHs. It's the one that we look for. And anybody testing for PETH, if they're testing for more, this is one of them. If you're just testing for one homolog, this is the one that you zero in on. But what they did was they had that initial result that they obtained before they adjusted the hematocrits. And then they had the adjusted hematocrit PETH determination. And all of this was done by preparing dried blood spots of these samples. And then they tested it and compared the adjusted hematocrit aliquot to the original aliquot. So if you had perfect agreement, that equaled 100%. If it come out 10% more, that would be 110%. So laying that background here, looking at this chart, there does seem to be some trends with how hematocrit goes back and forth, but it is not appearing to be all one way. It appears to go up and then back down. But more important for what we're doing here is that these results, the post-adjusted hematocrit samples versus the original hematocrit sample, all of those were within plus or minus 20% of the original value. And so this is important because we know that we cannot take these results and backtrack and determine time, dosage, and frequency. Too many variables. Clearly, this is one of the variables. But what we're looking for is abstinence detection. We're monitoring abstinence verification. And so whether it's 100 or whether it's 80, in our world and for the purpose of this test, that is really rather irrelevant. It's positive. And that means that the individual has not been abstinent over the past 2 to 4 weeks. Additionally, we get a lot of discussion about, can mouthwash produce PETH? So some mouthwashes can contain 10, 15, even 20% ethanol. That's a lot. And so by someone regularly using these ethanol-containing mouthwashes, is it possible to generate a positive PETH result? I had the privilege of working with a team from the University of Florida, and you can see them on the author line here. And this paper was recently accepted by the Journal of Analytical Toxicology, and these are the results that we found. It was determined through statistical analysis, power analysis, that we needed 15 volunteers to achieve an alpha of 0.05 to have enough statistical power. We recruited individuals and requested them to be abstinent 5 days prior to the study, and then 12 to 13 days during the study. We gave them pre-filled bottles of Listerine Cool Mint, and that has 21.6% ethanol. Man, that's a lot. And they were instructed to use it 4 times daily. We collected urine and dried blood spots at various points during the 2-week procedure. Here's a graphic of the study design. So on day 0, the females were subjected to a pregnancy test. We don't want to have any implications of alcohol and pregnancy in a research study, so we had to rule out anyone that was potentially pregnant and may not be aware of it yet. We collected a blood spot at day 0. We collected a urine ETG, ETS at day 0. And then they were given their pre-filled bottles. They went home. They gargled 4 times a day. And each day they collected a urine specimen. Then on day 6, they came back in. They collected a urine sample there at the study site, as well as another dry blood spot. Then they went home again, and they had 5 urine collections each day as they gargled 4 times per day with the ethanol-containing mouthwash. And then on the last day of the study, they came back into the study site, collected another dry blood spot in the urine. And so what we found, we had various ups and downs with ETG and ETS, as you would expect with somebody using mouthwash. And what we saw with the PETH was we really didn't see anything. The standard cutoff we use is 20. The limit of quantitation for our standard assay is 8. Our limit of detection is 3.2. So as you can see, we've got like these little values floating around in and around the limit of detection for the assay. And frankly, the day 0 samples had a little larger, but we 3.76 and 2.69 on our platform is kind of the same thing. That's not a statistical difference. And you can see that the 3 different times was significant overlap in what we found. So we concluded in that paper that the excessive use of mouthwash over a long period of time is not a reasonable explanation for producing a PETH greater than 20. Then the next question comes up about the hand sanitizer. This is probably the bigger question. A couple of years ago, there was an abstract published at a conference in Europe and they claimed some rather extraordinary levels based on using different ethanol preparations on their hands. When I was first made aware of that and I looked at it, I was like, that's not mirroring my observations. When we first launched this, we did these kinds of tests. We're all familiar with the scenario with ETG and urine back when that was first being launched. And so no one wants to launch a test knowingly producing the metabolite or analyte that you're looking for. So we analyzed ourselves after putting a whole lot of Purell. Back then, Purell was kind of the only one out there, at least I was aware of. And we just didn't see anything. So this non-peer-reviewed abstract at a conference just did not mirror our experience with dried blood spot PETH. So we repeated the experiment here. You know, our method has changed a little bit. Our testing has gotten a little more sensitive than what we had back in 2007. And so we registered 4 volunteers here at USDTL, and 3 of them self-reported as social drinkers. 1 reported as a teetotaler. We washed hands with soap and water. We used isopropanol disinfecting wipe on the puncture site, and then we collected a baseline DBS. Then we sanitized our hands with ethanol-based waterless hand sanitizers, and then we collected another DBS while the skin was still moist with the sanitizing agent. And so this is a graphical depiction of our study design: soap and water, isopropanol wipe, collect the baseline DBS, and then sanitize with the ethanol-based hand sanitizer, and then collect the post-ethanol-based hand sanitizer. These are our findings. And so our teetotaler was not detected either before or after the use of the ethanol-based hand sanitizer. Social drinker number 3 was not detected in both instances as well. Social drinker number 1 went from non-detected to 4, and social drinker number 2, who I guess is truly a social drinker, actually went down. They went from 28 down to 26. Analytically, 26 and 28 are the same number. That's not a statistical difference. They're kind of the same, if you will. So in our experiment, we repeated the same observation that we had, 13 years ago, and we just did not see any appreciable formation of PETH on dry blood spot. And so why could this be? So in correspondence with the authors, we kind of got some insight on that. My first question was, is when is that abstract going to be published and put through the full rigors of peer review? And I was informed that they don't intend to do that because I don't think that they have the data that they would like to have to support their findings. Also, it's also they did not have a before and after with regard to a teetotaler. And so we've got positive people versus positive people. And the one person that was self-reporting as a teetotaler had like 200 or 300 PETH. And it turns out that that one teetotaler did have a conflict of interest with kind of needing to show that PETH doesn't work. So you have to be careful with abstracts that look like a paper. Abstracts at a conference are generally not peer-reviewed. They're a first pass at the data. And they do look for people to propose questions and say, how can we show further data, further evidence to demonstrate this point? So we have to be careful of that. Even if the abstract is published in a journal supplement, they do have the look and feel. You print them out, it looks like a real journal article abstract. So you just have to be careful with that. However, this is clearly not enough. And so this is an N of 4. That study was an N of 3. I picked the N of 4 just to have one more than them. So, you know, we need more. I do have some more going through the lab, and hopefully we'll get enough to have a statistically significant enough sampling on this to either rule it in or rule it out. And so hopefully we'll see some of that early next year. But the University of Florida, again, was wanting to conduct a larger study about the excessive use of hand sanitizer. So this is kind of two different questions. What about the use of hand sanitizer right before a collection? Is that a problem? And then what about someone that's using a crazy amount of ethanol hand sanitizer, like a nurse? You know, a nurse can use hand sanitizers over 100 times a day. And so this is what we wanted to replicate. And so we had 15 volunteers again. We asked for abstinence 5 days prior, 12 to 13 days during the study. We gave them Purell Advanced Hand Sanitizer Refreshing Gel, very specific brand type. 70% ethanol. One pump is 1.75 milliliters approximately. And we asked them to use it 24 to 100 times daily and maintain a participant log of exactly when they were using the Purell. We collected urine and DBS, just like we did for the previous study. And here is the study guide. Again, check the ladies for unknown pregnancy, collected PETH in urine at the time of time 0, sent them home with the Purell, collected 5 urines each day, came back on site, collected another blood spot and urine at the study site, and then sent them home again, 5 urines using the Purell each time, an excessive number of times per day. And then on the last day of the study, brought them back in and collected a final dry blood spot and urine for ETG, ETS. And so here were our findings. So number one, this study is ongoing, and I was generously allowed by Dr. Reisfeld and Teitelbaum to share these data here today. These are incomplete, but we have 10 out of 15 participants completed at this time. 9 out of those 10 produced positive urine. And so that's as expected. At this time, no participant has provided a positive PETH. However, there was one participant that was detected at 13 nanograms per mil. So I was like, what's going on there? And so I wanted to take a deeper dive on this particular participant and take a look at the ETG, ETS, and the PETHs and how they evolved. So here we've got the day of the study. And on the vertical axis, we've got the measured concentration in nanogram per mil. And we're going to show the creatinine 100 normalized ETG for this participant. So we can see that we had zeros all the way up to day 11. And then at day 12, we popped to 1200. So that's a pretty significant jump. Not so sure that that's due to Purell. And then on day 13, we drop back down to 0. Layered on this, we have creatinine 100 normalized ETS. And so in the middle here, we have on day 6, it jumped a little bit, looks like about 100. On day 9, it went up to 200. On day 11, it was at about 200. On day 12, it went back down. On day 13, it went back to 0. And then we overlay the PETH. So we came into the study with a level of 5. On day 6, we're at 0. And then on day 13, day 13, it's at 13. It's ironic, I just realized that. And to blow this up a little bit to get a better look at it, there it is. So my interpretation of this is that this donor consumed some alcohol at some point prior to day 12. Don't know how much, because we don't know his rate of formation, his rate of elimination, a lot of other things. But in my interpretation, if this were someone who is manufacturing PETH due to Purell, this ETG and the ETS could not have been 0 on day 13. So this is my fault. There was an isolated period of ethanol consumption in the later half here, probably day 10, 11, 12, somewhere in there. And this is where we're seeing the 13 PETH. That's my take on it. If somebody else has another take, I'd love to hear it. But with that, that is the end of my presentation for today.
Subscribe to our channel to see more videos like this.